Hi, I'm Lily Kroll, and I will be teaching you about limiting reactants, excess reactants, and percent yields. Zinc and sulfur react to form zinc sulfide according to the equation. The equation is Zn plus S turns into ZnS. If 25 grams of zinc and 30 grams of sulfur are mixed, we have three questions that we need to answer. A. Which chemical is a limiting reactant? B. How many grams of Zn will be formed? C. How many grams of the excess will remain after the reaction is over? In order to do this equation, we need to get from grams of Zn to grams of ZnS. We start with 25 grams of Zn. Then, to cancel that out, we get the grams of Zn per mole of Zn. Once we cross out the grams of Zn, we're left with 1 mole of Zn on top. In order to cancel that out, you put 1 mole of Zn on the bottom, which is equal to 1 mole of ZnS, balanced out. Then from there, you have 1 mole of ZnS, and you want to convert that into grams of ZnS. So you look to see how many grams on the periodic table of ZnS are equal to 1 mole of ZnS. Then from there, you're able to cross out the moles of ZnS. Next, you multiply the top row and divide by the bottom row. In order to do this, you would do 25 times 1 times 1 times 97.3. You would get the sum of that, and then you would divide that by 65.3, and your answer turns into 37.2 grams of ZnS. Next, we need to go from grams S to grams ZnS. In order to do so, we have to convert on the table. We start with 30 grams of S, and to get rid of grams of S, we put 32.06 grams of S on the bottom per mole of S. That helps us get rid of grams of S. Now with 1 mole of S on the top, we put 1 mole of S on the bottom, and we do mole to mole. On top goes 1 mole of ZnS. This helps us cross out 1 mole of S on each the top and the bottom. Next, we have 1 mole of ZnS on the top. To cross that out, we put 1 mole of ZnS on the bottom. And to get the amount of grams per mole of ZnS, we go on the periodic table, and we got 97.3 also grams of ZnS. Now, in order to get the answer to this, we multiply the top by and divide it by the bottom. So in this case, you would do 30 times 1 times 1 times 97.3. Divide that number by 32.06, and your answer is 91.19 grams ZnS. The first question they want us to find out is which chemical is the limiting reactant. After finding our two answers, we see that 37.2 grams of ZnS is clearly a smaller number than 91.19 grams of ZnS. From there, we realize that the limiting reactant is 25 grams of Zn. So you write Lr to show that that is a limiting reactant because that product is a smaller number than 30 grams of S. Moving on to the second question, which is, how many grams of ZnS will be formed? In order to find out the answer to this question, you take both of the answers that you got in your final answers, and you pick the smallest of the two. So in this case, the answer is that 37.2 grams of ZnS will be formed because you take the smallest number out of the two tables you did. In order to find how many grams of the excess reactant will remain after the reaction is over, you must take the limiting reaction, which is grams in units of grams of Zn, and turn that into the units of grams of S. Here, what you do is you put 25 grams of Zn, which is, again, the limiting reactant, and then you convert that to grams per mole. So you put 1 mole of Zn on the top, and you put 65.39 grams of Zn on the bottom in order to get rid of the grams. And now, of course, you're left with 1 mole of Zn on top. Next, you put 1 mole of Zn on the bottom to cross that out, and you do mole to mole. Then you have 1 mole of S on top to cross that out with 1 mole of S on the bottom. And 1 mole of S is equal to 32.06 grams of S on top. And there you are in grams of S. Next, just like the other ones, you multiply the top and divide that answer by the bottom. So you do 25 times 1 times 1 times 32.06. Take that number and divide that by 65.39. Your answer should be 12.25 grams of S. Now you take your 30 grams of S, which is your excess reactant, and subtract that by the 12. You take the 30 grams of S and you subtract that by 12.25 grams of S. Right there. And your answer should be 17.75 grams of S. And that answers the question of how many grams of the excess reactant will remain after the reaction is over. Now we are going to do a percent yield problem. And we are going to do an example. The question is saying 30 grams of sodium phosphate was added to a solution containing 30 grams calcium nitrate. Calcium phosphate was precipitated according to the following equation. The equation is below. 2Na3PO4 plus 3CaNO3 turns into 6NaNO3 plus 1Ca3PO4 . Next, it tells us that 25 grams of calcium phosphate were recovered. It's telling us that now we need to calculate the percent yield. Now what I'm going to do is convert from grams of Na3PO4, and I want to get to grams of Ca3PO4. What I do is I take the 30 grams of sodium phosphate, which is grams of Na3PO4, place it on top. Then to cancel that out, I put 1 mole of Na3PO4 over 163.2 grams of NO3PO4. Then I can cross out the grams. Next, with 1 mole of Na3PO4 on top, I put 1 mole of Na3PO4 on the bottom. To cancel that out, I put that is a mole to mole ratio right there, and then I put 1 mole of Ca3PO4 on top. Then, in order to get rid of that, moles of Ca3PO4, I put that also on the bottom. Now I got to what I would like to get by going to the periodic table and getting 309.3 grams of Ca3PO4, and that is the unit, grams of Ca3PO4. And I found that unit from grams of Na3PO4. I converted into grams of Ca3PO4. In order to get the answer to this equation, to this chart, I do 30 times 1 times 1 times 309.3. And once I get that answer, I divide that by 163.2. And from there, the answer should be 56.85 grams of Ca3 PO42. Next, what we are going to do is we are going to convert the grams of CaNO32 to also grams of CaPO42. So, in order to do that, we start with 30 grams of CaNO32. And remember, we want to get that to grams of CaPO42. So what you do is you take the grams of CaNO32 and you put that on the bottom to cross it out. In order to cross that out, you would put 1 mole on top because that is the mole to gram ratio. So with 1 mole of CaNO32 on top, you also want to get moles of CaNO32. So you have to look at the equation, at the list before, see how it says 3 moles of CaNO32. That's because when it's balanced, you have to make sure when you do the mole-to-mole ratio that is the balanced number right here. That is crucial. So here you cross out the moles. So now on top, it's mole to mole, so you put 3 moles of CaNO32 on the bottom, and above that is 1 mole of CaPO42. So now you're at CaPO42, and that's what we're trying to get, but we're trying to get grams instead of moles. So now you have this mole, which you don't want, so you cross that out by putting that on the bottom. So now above that is 309.3 grams of CaPO42 is a ratio to 1 mole of CaPO42. So once you have the right units that you were trying to convert, this one, your answer should be 18.92 grams CaPO42. And just to remind you how you get that answer, you multiply 30 times 1 times 1, divide that number by 163.4 grams times 3. So then, my mistake, you do 30 times 1 times 1 times 309.3 grams. Then you take the bottom, which would be 1 times 163.4 times 3, and your answer should be 18.92 grams of CaPO42. Now you see that out of 56.85 and 18.92, that 18.92 is how many grams of that will be formed because it is the smaller number coming from the limiting reaction. So you take that number, place that on the bottom, and above that goes 25 because of the reason that on the question it actually stated 25 grams of calcium phosphate were recovered. So that's important that you save that part for after when we're doing this to get the percent yield. So that's why you put the 25 on top because that was recovered, and the amount that could be made was 18.92. You times that by 100, and your answer is 132%. And that is your percent yield. This is how you solve for a percent yield in a limiting and excess reactant percent yield equation. So this is taking it one step further than the limiting and excess reactants. Thank you for watching.